Okay, so we're going to jump into solving quadratic equations, and solving quadratic equations are different than solving linear equations, and there are so many different ways that you can approach quadratic equations, and it really depends on what the equation looks like and how you should approach it. So we're going to first look at solving quadratic equations by factoring. We're going to look at using the square root method when possible. And if it's not possible, we can manipulate our quadratic equation by completing the square to use the square root method. So we'll look at that. And then we'll look at deriving the quadratic formula by completing the square method. And then there's a rule called the discriminant that will tell you how many solutions that your system of equation, or not system of equations, your quadratic equation has, and what type. Is it a real solution? Is there one or two, or is it a imaginary number complex solution? So quadratic equations are in the form as the following: that you have ax squared plus bx plus c equals 0. We have to have that stipulation that a can't be 0, because if a was 0, that x squared term would go away, and this would then be a linear equation. Okay, so quadratic equations. So for this example, we have the problem x all times the quantity x plus 3, and then minus 10 equals 0. So same thing with linear equations. It might be useful to distribute and simplify. So that's the first thing that I would do there. I notice I can distribute this x inside the parentheses of x, the quantity x plus 3. So x times x gives us x squared plus x times 3, so 3x. And then outside the parentheses, let's bring down the minus 10 equals 0. Okay, so this is quadratic equation. Everything is already just one side of the equation, and that's equal to 0. So it's set up in the form that we can try to solve this by factoring. This is the most easiest form to factor when your coefficient, the number in front of the x squared term, is 1. First thing you want to try to do is see, are there two numbers that multiply to give us this constant negative 10? How I denote it up here, you guys might denote it a little differently, but it's the same sort of idea. You might do your little x here and put your numbers. I just never kind of learned it that way, and I just kind of keep things organized this way. But we're looking for something that multiply, two numbers that multiply to give us negative 10 and add to give us 3. So just think of multiples of 10. I notice that I'm getting a negative number, so one has to be negative and one has to be positive when I multiply to get a negative. And I notice that when I sum to get those two numbers together, I have a positive number, so the larger one is positive. And 5 and negative 2, that multiplies to negative 10, but if we add those, this is negative 2. And so quickly we can factor this as x plus 5 all times x minus 2. This is equal to 0. We're using this principle, a zero product principle, that if you multiply two things together and you get 0, then either A is equal to 0 or B is equal to 0. So we're using that property here that either x plus 5 equals 0 or and x minus 2 is equal to 0. So if I solve for x here, subtract 5 on both sides, I get x equals negative 5. And if I add 2 on both sides there, I get x equals 2. There were no stipulations at the beginning that we had to make any restrictions. There's no variables in the denominator. And so our solution is negative 5 and 2. Okay, so let's look at an example now. Similar, we're going to need to distribute and simplify if possible. And so I notice here I can distribute my 6 to each term inside the parentheses. That quantity is p squared minus 1 inside the parentheses, and that's equal to 5p. So distributing our 6, we get 6 times p squared is 6p squared. 6 times -1, so minus 6 is equal to 5p. So get this set equal to 0. And so if we subtract 5p on both sides, we get 6p squared minus 5p minus 6 is equal to 0. Okay, so I noticed that factoring this is not going to be as easy as it was as a problem above, because my coefficient in front of my p squared is not 1. And so I tend to like to use what is called the AC method, where I figure out what multiplies to the multiple of what a times c is. And so if I do that in my case, I have 6 times -6, which is -36. So we're looking for something that multiplies to give us -36. But for the addition piece, those two numbers have to add to the middle term, which is b is a -5. So notice that the 2 multiple gives me a negative, one's positive, one's negative then, and when I sum the two numbers, it's negative, so it's larger one, it's going to have to be negative. So I start to think about two numbers that multiply to give me 36, like 6 and 6, but I know that doesn't sum to a -5. 9 times 4 is 36. So if I did a -9 and a +4, that multiplies to -36 and adds to -5. So the trick, once you figure out those two numbers, is to go back and let's rewrite this middle term using those two numbers we found. So a lot of times in mathematics, we kind of manipulate things in order to make them simpler and so that we could solve them. So instead of writing this as -5p, I'm going to write it as -9p plus 4p. So let's rewrite this, 6p squared. And so instead of -5p, I'm going to rewrite this as -9p plus 4p minus 6 is equal to 0. So when we're trying to factor things, if you have 4 terms, the trick is to try sometimes to factor by grouping. And we just manipulated this to do this by factoring by grouping. So you group the first 2 terms together and you pull out what they both have in common. So looking at 6 and 9, I know they both have a 3 in common, and a p squared and a p both have a single p in common. So I'm going to pull out a 3p from both of those terms. That would leave me with a 2p minus 3. So same idea, looking at the last 2 terms over here, 4p minus 6, I'm looking at what they both have in common and pulling it out. They both have a 2 in common, 4 and 6 do, so let's pull out a positive 2. And that would leave me with 2p minus 3, and the parentheses equals 0. So as long as you chose the correct 2 numbers to rewrite your middle term, and you pulled out the right things, you should have the same thing inside your parentheses. So now what we're going to do is we're going to pull out that whole parentheses from both of those groupings. We're going to pull out this 2p minus 3. And if we do that, we're left with 3p for the first piece and plus a 2 equals 0. So the whole point of solving by factoring is get everything to one side and then factor it. And then once we've got it factored, we can set each factor equal to 0 and solve for the variable. And so we're looking at when is 2p minus 3 equal to 0? And when is 3p plus 2 equal to 0? So if we add 3 to both sides for the first equation, we get 2p equals 3. Divide both sides by 2, we get p equals 3/2.
Professor?
Yes.
How'd you get 3p plus 2?
Okay. Because basically right here, notice inside the parentheses, we have this 2p minus 3 in common. So if I pull that out, so I'm like factoring out a parentheses. So if I factor it out of this piece, you're left with a 3p here. And then plus, and I'm factoring it out of this piece, so I'm left with the 2. So think of it as, to get back above, I'm like distributing this whole piece to the 3p, and that would give me what was above. Or distributing this to the 2 would get me what I had above.
Oh, okay. And then you would just write the 2p minus 3 just once?
Yes, because you're pulling it out of this and this. And so
Uh,
all you're left with is that 3p and the plus 2 here.
okay, thank you.
You're welcome. So now we're looking at 3p plus 2 equal to 0. And so get the term with p by itself, we would subtract 2. So we get 3p equals negative 2. Divide both sides by 3 to get p by itself. You get p is equal to negative 2/3. So there were no restrictions that we had to make at the beginning because we didn't have any variables in the denominator. And so this should be our solution.
I have another question about this question.
Uh-huh.
So when you got the negative 9p and the negative 9p plus 4p, or 4p, no, 4p, yeah. Where did that come from? Because I know it came from when we were saying that negative 9 and 4.
Right.
I'm just confused how to plug that in.
Okay. So when we're factoring quadratic equations and that coefficient in front of that variable square term isn't 1, you have to go about factoring it a different way. And it's called this AC method, and it's a trick that can be used, and it can only be used if that polynomial is factorable. And so the trick is the first to look at your coefficient in front of the square, which in our case was 6 in this case. And I'm sorry, it has to be set equal to 0 first when you're doing this. And then your C value, which was negative 6. So I want to multiply those two numbers together. And that is what the number I'm looking for, two numbers to multiply to give me this multiple of negative 36. And then the trick says, well, you also have to, those two numbers have to satisfy that they multiply to this AC, but they also have to satisfy that they add to whatever that coefficient is in front of this single variable, not the squared one. So that in this case was negative 5. And so that's where we played around and figured out negative 9 times 4 are those two numbers that multiply to negative 36 and add to negative 5. So once that's done, so we originally had the 6p squared minus 5p minus 6. Well, we found two numbers, and the whole kind of point was we found the two numbers that multiplied that gave us this and add to give us this. Well, we can rewrite negative 5. We can rewrite this negative 5p as same thing as negative 9p plus 4p. Because, right, if we sum these two together, it gets back to what we originally have. And a lot of times, again, in mathematics, we kind of manipulate things. We multiply things by a fancy 1 to get rid of things, or we multiply both sides of an equation to get rid of, denominators. And so we're just going to manipulate this problem, rewriting the middle term with the two numbers we found in the variable we're using. And then the trick, once you found those two numbers, and again, this will always work for factoring if it's factorable, and you can find those two numbers, which we did. The trick is always to go then to do the factoring by grouping method. So these are going to be some things that you might want to just kind of look up again, how to factor by grouping or factoring ax squared plus bx plus c. Some of you could have done this by just trial and error and looking at it. This method to me always works, and when I have bigger numbers, to me it's just easier and just faster, even though it's taking me a while to explain the process right now. But grouping the first two terms together again, you want to notice what they have in common, and we notice that, look at the first coefficient, 6 and negative 9, and those both have 3 in common. And I'm kind of repeating what I just did before though. And p squared and p just have a single p in common. So if you think, pull out 3p from this value, you think of what you're left with. Well, 3 times 2 is 6. P times p squared, or p times p is p squared. So this should be a 2p left in this piece. And then if we pull out a negative 3p from the second piece, well, I know I need a negative. 3 times negative 3 is negative 9. And I pulled out this p, so there's no p left. Same kind of idea here. Look at what they both have in common. 4 and 6 have a 2 in common. You can either pull out a negative 2 or a positive 2. But our whole goal is to have the same thing inside the parentheses after we pull this out. And so if you don't have the same thing inside the parentheses, you didn't pull the correct thing out. So if I pull out a positive 2 from 4p, well, that will leave me with a 2p. And if I pull out a positive 2 from negative 3, I'm sorry, negative 6, I get negative 3. So again, what we wanted was that factor inside the parentheses to be the same. So think of it as pulling it out. So you're pulling out 2p minus 3. Well, if you pull it out, you're trying to get this whole piece back. What you're left with is just a 3p. And then this plus, and if we pull this 3p minus, or 2p minus 3 out of this term, you're just left with that 2. And then again, you'd go back and solve. So hopefully me going back and explaining the process again helped. Maybe you were too busy kind of writing down things and didn't see the explanation.
That was perfect. Thank you so much.
Okay. Okay, so notice this next example. We have a rational equation again. And so again, when we're starting with a rational equation, variables in the denominator, we have to make some restrictions. And so it's helpful to see it now and write it out so you don't forget about it later. So we're going to have some restrictions here because we can't have any variable that sets our denominator equal to 0. So x plus 4 can't be 0. So we know x cannot be negative 4. So we also have a denominator here, x minus 2. So we can't have a value of x that sets that equal to 0. So we know x cannot be 2. So we're going to approach it the same way that we did with the last section when we ended up with rational equations and then it was a linear equation. We're going to clear our fractions by multiplying by the LCD. So we have an LCD. We need both of those denominators in there, x plus 4 and x minus 2. So we want to multiply the LCD to both sides of the equation. Sorry, got the parentheses in the wrong spot. So we have x plus 4, x minus 2, all times the left-hand side, 5, all over x plus 4 is equal to, we're going to distribute, when I write this out, this LCD to each piece. So we have 4 times our LCD, which was x plus 4, x minus 2, plus, and then we have the second piece on the right-hand side, 3 all over x minus 2, and that is also multiplied by the LCD x plus 4, x minus 2. Okay, so let's simplify. Denominators go away, x plus 4 cancels there, and we're left with 5 times the quantity x minus 2. So let's just distribute and bring that down right now. So 5 times x is 5x, minus 5 times 2, so minus 10. So this is equal to, so nothing simplifies here. There's no fraction with this term of just 4. And so sometimes students just forget to multiply the LCD to terms that don't have a fraction. So just try not to do that. So let's distribute that x plus 4 times x minus 2 as we bring it down. And so x times x is x squared. X times negative 2, we get negative 2x. 4 times x is plus 4x. And 4 times negative 2 gives us minus 8. And then we have plus x minus 2's cancel, and we're going to distribute our 3 while we bring this down to the quantity x plus 4. So 3 times x is 3x, plus 3 times 4 is 12. Okay, so we need to simplify and then get everything to one side of the equation. So left-hand side is already simplified, 5x minus 10. Let's distribute on the right-hand side that 4. So we have 4x squared. 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. 4 times 2x is plus 16x. And 4 times negative 8, that gives me negative 32. And then let's bring down the 3x plus 12. So I want you guys to get used to, when you're writing out your solutions, bringing down pieces of your equation that you haven't used or haven't simplified yet. Because I know a lot of students will like to work pieces here and then down here, and then they forget about moving things down. And it's just more room for error. This also, when you guys are taking your tests, I do partial credit. So if I can follow your reasoning and stuff, and it's clear, you're going to get more points than if I can't understand what you're doing or your jumping spots. So just to be aware of that. Okay, so again, I'm going to bring down 5x minus 10. I haven't simplified that, but the right-hand side, I can combine some like terms. I'm going to bring down my 4x squared because there's no other term that has an x squared. Let's combine negative 8x plus 16x. That gives me an 8x. And 8x plus this 3x here gives me plus 11x. Combine our constants. So we have a negative 32 on this side plus a 12. So this gives me negative 20. So quadratic equations, you want to set equal to 0. And so let's subtract 5x and let's subtract 20. I'm sorry, let's add 10 to both sides. So we're going to subtract 5x. And add 10. So we can get this set equal to 0. Okay, so we have 0 equals 4x squared, 11x minus 5x, so this is plus 6x, and negative 20 plus 10, this is minus 10. Okay, so we want to factor this. Anytime you're trying to factor, it's easiest if you can pull out the greatest common factor, if all of your terms have a greatest common factor. And so notice 4, 6, and 10 are all divisible by 2. And so it just will make it easier in smaller numbers if we can factor that 2 out first. So let's pull a 2 out of all 3 of those terms on the right-hand side. And so if we pull out a 2, we're left with 2x squared plus 3x minus 5 inside the parentheses. Okay, so I want to factor this. I'm going to do some side work because I noticed that this is a coefficient of not 1 in front of my x squared term. So let's look at 2x squared plus 3x minus 5. So again, I would use my AC method. So I would look at what is my coefficient in front of the x squared term, which is 2. Multiply it by my constant. Make sure you carry the sign negative 5. So if I multiply those two numbers together, I get negative 10. And then I look at my middle term, my b value. My b value in this instance is positive 3. So thinking of two numbers that multiply to negative 10 and add to 3. we used those numbers before, 5 and -2, multiply it to a -10 and add to a +3. So this is where we're going to use the trick. We're going to go back up here. We're going to manipulate this and rewrite that middle term using those two coefficients, or those two, using them as coefficient in front of x and rewriting it as a sum. So if I do that, I have 2x squared. So instead of writing 3x, I'm going to write it as, to me, it's easier. I noticed that writing the 2 is better first, just because that has something in common with the first term, and the 5 has something in common with the last term. So I'm going to rewrite it with the -2 first. So instead of actually plus, I'm going to put minus 2x plus 5x. And then we have this minus 5 over here. So now group the first two terms together, the last two terms together, and pull out what they have in common in the first two terms. So 2x squared minus 2x, those both have a 2x in common. If you pull that out, you're left with a single x, and then you're left with a -1. So 5x and -5, the last two terms, those both have a +5 in common. And so if we pull a +5 out of these both two terms, you're left with x minus 1. So notice what's inside the parentheses is the exact same thing. And so if we pull out x minus 1 from this whole grouping right here, you are left with just 2x. And if we pull out the x minus 1 from the second grouping over here, you're just left with the positive plus 5. Okay, so that was just kind of some side work. So it wasn't so messy over here. But it's kind of important too to show side work, but not have it intertwined in between your showing your steps. Okay, so we have 2. We need to bring down that constant coefficient out here. All times x minus 1. All times 2x plus 5. So we've got it factored, everything factored on one side, and it's set equal to 0. So we're going to set each factor equal to 0, 2 equals 0, x minus 1 equals to 0, and 2x plus 5 equals 0. Well, constant can never equal 0 unless it's 0 itself. So that's never true. The x minus 1 equals 0 when x is equal to 1, adding 1 to both sides of our equation. Here, if we add 5 to both sides, we get 2x equals, actually subtract 5 on both sides. So we get 2x equals -5 and divide by 2. So we get x equals -5/2. So we want to go back and check our restrictions. I don't remember, was that one of them? So our restrictions from above was x couldn't be -4 and x couldn't be 2. We got two answers that were not those, and so our solution is -5/2 and +1. Okay, so the next problem, we can kind of solve what we were doing here and expand things, get everything to one side, and then try to factor it. But sometimes there's either easier methods. There's, all these methods will get you to the same place and the right solution if you're following it correctly. But notice here, if I was to solve this 3z minus 2, that all in parentheses, and that quantity squared equals 4. If I was to do what I was just doing, I'd have to FOIL this out, I'd have to subtract 4, and then I would have to try to factor it. This on the left-hand side is a perfect square. Notice that the whole quantity on that left-hand side is quantity square. And also notice on the The left-hand side was quantity squared. The right-hand side, notice that 4, it doesn't have a variable over here. So this is where we can use what is called the square root method. And it will just be so much faster and easier to go this route than the other route. So basically, if you have some value, quantity squared equals b, where let's say a is some expression. How about some linear expression? And b is a constant. Then we can do the following. Basically, we could get rid of the square on this left-hand side by taking the square root of both sides. So if I took the square root of one side of an equal sign, I have to take the square root of the other side of an equal sign. The one thing that we have to be careful though is that we can square a negative number and get back something. And so this is where we have to put, when you're square rooting both sides of an equation, a plus or minus in front of it, at least one of these square roots. Putting it in front of both of them will give you the same as just putting it in front of one. I tend to like to put it in front of the one with a constant that I'm simplifying, but it doesn't matter. So if we take the square root of a squared, and this is equal to plus or minus the square root of b, then we can say that a is equal to plus or minus root b. And so notice that this is a linear expression. Quantity is squared, and then it's equal to a constant. So we can use the square root method to help us solve this. And so if it's not in this form, but could be manipulated in this form, so sometimes maybe this had been 3z minus 2 squared minus 4 equals 0. Well, we can manipulate this by isolating the quantity squared by adding 4 to both sides. So sometimes we can just quickly manipulate it to use that square root method. So let's take the square root of both sides. So we have the square root of 3z minus 2 quantity squared equals plus or minus the square root of 4. Well, square root cancels out the square here because it's a single term squared. Think about it like that. So this is just 3z minus 2 is equal to plus or minus the square root of 4. Well, the number you square to get 4 is 2. So you technically have two separate equations here. 3z minus 2 equals positive 2, and 3z minus 2 equals negative 2. So solve each linear equation. If you add 2 to both sides for the first equation, you get 3z is equal to 2 plus 2, so 4. Divide by 3, we get z is 4/3. So over here, second equation, if we added 2 to both sides, we get 3z equals, well, negative 2 plus 2 is 0. Divide by 3. Well, 0 over a number other than 0 is okay, and that's equal to 0. So we have two solutions. We have 4/3 and 0. Okay, so this is probably a great spot to stop. I kind of wanted to show you doing it the other method, but we really are almost out of time. I definitely did not get as far as I expected to this week, which is fine. But we might pick up some of the pace next week to catch up a little bit. Again, a lot of the stuff that we're doing this chapter and a few of the chapters at the beginning of this course should be repeat of material. I mentioned that I taught this course this summer, and so I do have videos that you guys can refer back to of me teaching the same materials from the same book, but it's probably different problems. So you're going to get more, have more problems to watch and look at if you needed to. I'll try to remember to post that on Canvas so you have a direct link to that page in YouTube if you like. So let me stop this.